we are going to begin looking at systems of equations and how to solve them. And in today's notes, we're going to look at the method of graphing to solve a system. So a system of equations is just two or more equations, and that's called a system. And the solution to a system of equations, if we use graphing as the method to find the solution, is a point that makes both equations true. So it's an ordered pair, an xy pair, a single point that makes both equations true. And so to do this graphically, the goal here is to find where these two equations intersect. So we're going to be graphing them both on the same coordinate plane and just finding the point where they cross. So the first example here, we have two equations, y equals negative 2x plus 1 and y equals negative 1/3 x minus 4. So we're just going to graph these both and see what happens. So the first one, negative 2x plus 1, we start at 1 on the y-axis. Slope is negative 2, or negative 2 over 1, so that's down 2, right 1. Keep going. It's really important, especially on this lesson, that you bring the line all the way across the graph so you can really see where the two lines intersect. The next equation is y equals negative 1/3 x minus 4. We're going to start down 4, down 4 this time. Slope is negative 1 over 3, so down 1, right 3. We're up and left. And we can see where they're going to cross. All right, so these two lines intersected right here. So this is the solution to the system. So we just have to name this ordered pair. And that is the ordered pair 3, negative 5. And that's the solution to the system. If we plugged in these values for x and y in both of these equations, they would make both of the equations true. Example B, y equals negative 3 over 2x minus 4, and y equals 1/2 x plus 4. So let's start with the first one. Down 4 on the y-axis. The slope is negative 3 over 2, so down 3, right 2. Kind of off the graph on this first one, so we can go backwards. Up 3, left 2. Do that a few times. So there's the first line. And then we have 1/2 x plus 4, so start up at 4, up 1 over 2, or down 1, left 2. And here's the solution right there, which is the point negative 4, 2. Again, we're just graphing both lines and seeing where they cross. Now, not every pair of equations will cross, and not every pair of equations will cross at a nice intersection like this, but for these notes, these are all set up so that they get a nice clean solution. All right, y equals negative 3 for part C, and y equals negative 3 over 2x plus 6. Remember, y equals negative 3 has a slope of 0. So we go to negative 3 here, and then the line is just horizontal. And then y equals negative 3 over 2x plus 6. We start at 6. We're going to go down 3 over 2 to right there. Right on the edge, which is the point 6, negative 3. This point right here. So it is important that, especially for situations like this where it's right on the edge of our graph, it's important that you make sure you draw clearly, try to stay as straight as possible, and that way you can really see where those lines intersect. Example D, y equals 4 and x equals negative 2. Well, again, y equals 4 is a slope of 0, so horizontal, just like this. And x equals negative 2, remember this is a vertical line through negative 2 on the x-axis. So the point right here where they intersect is actually pretty simple because it's negative 2, 4, which if you look at the equations, match up with those x and y values. So that one's pretty straightforward there. They cross at the point negative 2, 4. Okay, y equals negative 2/3 x plus 1, for example E, and 3x minus 3y equals 12. Now we're going to have to solve this one for y first, but we can graph the first one, so let's go ahead and do that. We start up at 1, and then negative 2/3 for the slope, so down 2 over 3, or up to left 3. So there's the first one. But now we have to solve this one for y. So first thing we're going to do is subtract 3x from both sides. Remember, you want to write the x term first because you want it slope-intercept form. So negative 3x, positive 12. Then divide everything by negative 3. So y equals 1x, positive 1x, minus 4. So we'll graph this. Start down at negative 4. Slope is 1, or 1 over 1. So up 1 over 1 here. And the solution is the point 3, negative 1. Right there, 3, negative 1. So if your equation is not in slope-intercept form to begin with, you need to put it in slope-intercept form so that you can graph the equation on the same graph. Example F, 2y minus 4x equals 6. We'll have to solve that one. 2y minus 4x equals 6. And then y equals negative 1/3 x minus 4. Well, we can go ahead and graph that. So start down at negative 4, and then down 1, right 3. Like that. Making sure the line is nice and straight, or at least mostly nice and straight. Okay, so let's solve this for y. So we're going to add 4x first. So 2y equals, write the 4x first, and then the positive 6. Divide everything by 2. So y equals 2x plus 3. Starting at 3, and then up 2 over 1, or down 2 and left 1 for the slope. And there's the intersection point at negative 3, negative 3. Okay, so there you have it. So the idea, remember, is to just graph both lines on the same coordinate plane and then find the point where they cross, and that is the solution to the system. And if you want to check your work, just plug in the x value here for all the x's and the y value for all the y's, and you can just check that and make sure that those numbers make the two equations true.